x negative 2y equals negative 7. And that's over x plus y equals 2.
And what are we doing?
Write it in slope-intercept form.
Yes, slope-intercept form.
Write it in slope-intercept form. Okay, so this one is a slope-intercept. This is problem number 3. Slope-intercept form. What does that mean? Y equals mx plus b. Yes. Okay, so that implies that I need to move this x over and this x over by just putting the x in its opposite. The opposite x. If it was 3x, I'm putting negative 3x. If it was negative 5x, I'm putting positive 5x. I'm just grabbing the x and putting its opposite over there. So now I have negative 2y equals negative x minus 7. And I have y equals negative x plus 2. Okay? And then I want to divide out whatever's in front of the y. This one doesn't have anything. This has a negative 2. So I want to divide that out, and everybody on the block gets that paper. So I got y equals a positive x, a positive 1 over 2x. See how I split that away? I don't put the x above it. X is separate. Remember, it says y equals mx plus b. mx. So we separate it, right? Right. Good. So then I've got, and that's a negative. Negative makes it positive, and that's why it's 1/2. Then I've got another negative and a negative, so that makes another positive, and it's just 7 over 2. Okay? Which in this case, you can break it down into 3 1/2. Okay? Alright, and the next one is the same. So it's just y is equal to negative x plus 2. And so what does it ask me? The problem asks me something specific. It says, determine without solving the system whether the system is exactly one solution, no solution, or infinite. So without graphing it or anything, tell me what they are. Well, the thing is if they're parallel, we know that they're what? Parallel implies that they are not touching. So they are not consistent. Okay? If they cross any way, shape, or form, perpendicular, if they cross any shape or form, that implies that they are consistent. Oh, one final thing. If they are the same line, that implies that they are dependent. Okay, so if they're dependent, then what? Well, first of all, we need to know what makes these things happen. M1 equals M2, and B1 does not equal B2. Oh. Whereas, when they're the same line, M1 equals M2, and B1 equals B2. These will be the same exact equation. Or they'll have the same slope, right? They'll have the same intersect. In this case, are they the same slope? That's the easiest one. M1 does not equal M2. The slope doesn't equal each other. They're not equal. They're not the same. This is a half. This is a 1. They're not the same. So guess what? They're consistent. Does that make sense? Okay? They're consistent. All right? So, now we just jump over here to this other board, and we keep it rolling. Read me 6.
2x negative 3y equals negative 1. And x negative 4y equals negative 8.
Okay? Again, this is problem number 6. Problem number 6. Okay? So, what we got to do is, I'm assuming we're finding the intersection.
Yes.
Okay?
What's
So, to find the intersection, the easiest way is usually to just
count?
to linear combination, right? So, I need to make this x a 2, or this 4, this 1 a 2, or this 4 a 3. What's easier? A 2 into a 1, or a 3 into a 4? A 1 into a 2?
Yeah.
Yeah. So, I multiply this equation, and I want to make it opposite 2, so a negative 2. So, what times 1 is 2? 2. So, I'm going to multiply by a negative 2. Everybody on the block gets the paper. Bam, bam, bam. So, I got negative 2x plus 8y equals 16, because it changes all their signs. Okay? And then up here I got 2x minus 3y equals negative 1. I add them up, and I get these cancel, and I get 5y equals 15. Okay? That's not bad. Divide by 5, divide by 5, I get y is equal to 3. Is there a solution? Yes. Therefore, it can't be dependent. It can't be inconsistent. So it's not parallel, and it's not the same line. They cross. Where do they cross? That's half my solution. I have to find the other half. That's 1 out of 2 variables. 1 out of 2 is half. So now, what's the easiest variable? And take a look up here. This one has an x all by itself. I already have y. Why not get the one with the x by itself? So then I have x minus 4 times y, which is 3, equals negative 8. X minus 12 equals negative 8. Add 12, add 12. X equals, now you want to say 20, it's not 20, it's 4.
Oh, so D.
Okay? So, the intersection is at 4, 3. Not 3, 4. Just because we found 3 first.
Oh, I got you.
Just because we found 3 first doesn't mean nothing.
That's the y, I got you.
Got it?
That was something for y, and we were, okay.
Yeah.
Yeah, see, that's...
And that's where it'll have an answer there too, huh?
Yep, that's why.
Yeah. Very important. Okay, moving on up. Okay, next one. We're on a roll. 7. Problem number 7. Read it to me.
Y equals negative x plus 3.
Okay?
Y equals x negative 5.
Okay? Is that right? This is problem number 7.
Oh, negative 5.
Oh, negative 5. So, what?
It's y equals x negative 5.
X minus 5?
Yeah, minus 5, sorry.
Negative?
No,
X.
no negative there. Okay, sorry.
That's okay. Just want to get it right. Okay. Me too. So, it's okay. Alright, so we got y equals negative x plus 3. And y equals x minus 5.
Yes.
And we're going gonna find the intersection?
What is the solution of the system?
Yes. Find the intersection. Okay, so here's the cool thing. We know that the slopes aren't the same, right? Right off the bat, so I know they intersect. Okay, so where do they intersect? Now this is one we could plug in. We could. Because look, this could be a substitution one. This is y. So x minus 5 equals minus x plus 3. And it looks like the x's are canceling out, doesn't it? Because one's minus, one's plus. But you have to remember, grab the lowest x, do the opposite, and what happens? It's 2x minus 5 equals 3. That's key. And now, I add 5, and I get 2x equals 8. And I divide by 2, and I get x equals 4. That wasn't too bad. Instead of moving things all around, and this actually wasn't that bad of a substitution problem. Okay? But now that's only half the problem. I need to find y. So which one am I going to plug it in? And I like this one. Y. Y's alone, for one, and x is positive. I don't have to deal with a negative number that I'm plugging in. What if I'm plugging in a negative? Then I got negative, I can make mistakes. Right? So, the first thing I look at is if the y's positive. Well, they both are. So now I want to make sure the x is positive. If I have a choice, right? Boom. Or there's no fraction. It's always no fraction too, you know? Okay, so we got y is equal to 4 minus 5. Wow, that's like almost like chapter 2, like that test I was handing out to you guys. This isn't that hard, right? Y is equal to minus 1. So, therefore, there's an intersection at 4, negative 1. And hopefully, that answers on the test. Is there? Ow. There's another one. We're at 12 minutes. We got 3 minutes to solve this other one. You think we can do it? 2 minutes, actually. They're at 13 minutes. 8. 8. Let's see if we can get 8 now. Think we can? What is it?
4x
4x
plus 3y
plus 3y
equals 14.
equals 14.
6x
6x
plus 3y
plus 3y
equals 24.
equals 24. Oh,
This is a big one.
this one ain't bad at all.
These two.
All right. The 3's and the 3's make one an opposite. But to do that, I need to multiply everything by a negative. So I got 4x plus 3y equals 14. And negative 6x minus 3y equals negative 24. Add them up. These cancel. I've got negative 2x equals negative 10. Divide by negative 2. And I get x equals 5. Okay? Which y is easiest? They both. So I'm going to grab the one that's the lowest. This one has the lowest number. So 4 times 5 plus 3y equals 14. So 20 plus 3y equals 14. Minus 20 minus 20. And I get 3y equals minus 6. So then I get divide by 3, divide by 3. Y equals minus 2. Therefore, there's an intersection at 5 minus 2. Pow! Did we do it?